This video will go over the last panel in the parametric equation trifold. On the back panel we have this particular word problem about projection motion. It says that Jim hits a golf ball at the initial velocity of 150 feet per second at an angle 30 degrees to the horizontal. Our job is to find parametric equations using these formulas, and then we need to answer the question about how long the ball is in the air and how far did it actually travel horizontally. And then we can also answer questions about what was the maximum height reached by the ball, as well as when did it reach the maximum height. So first things first, we need to realize that in our equations we need to know a v naught, that's our initial velocity. That's going to be our 150 feet per second. We also need a theta, an angle, and we're going to find that to be our 30 degrees. G is actually going to be gravity, and because we're using feet per second, this is going to be 32 feet per second squared. We also need to find the initial height. Because he's hitting a golf ball, we're going to assume that he's hitting it off the ground, so our initial height is going to be 0. So now that we have all our information, let's see if we can come up with our parametric equations. So for x, we know it's going to be our initial velocity of 150 feet per second times cosine of 30 degrees times t. So we actually know the value of cosine of 30 degrees, so we're going to let that be x is equal to 150. Cosine of 30 degrees is the square root of 3 over 2. So we can see this is going to be 75 square root of 3 times t. So let's do something similar for the y. For y, we know it's going to be negative 1/2 32 feet per second squared times t squared, plus our initial velocity, which is 150 feet per second, times sine of 30 degrees times t, and then our initial height of 0. So we can find y is going to be a negative 16t squared. We know sine of 30 degrees is 1/2, so plus 75t, and then plus 0. So we have our parametric equations right here. Moving right along, we see for part B we need to find how long is the ball in the air. So really what we want to know is when is y equal to 0. Because while it's in the air, the height will be bigger than 0. So when y does equal to 0, that is when it's on the ground. So I'm going to use my y equation and say 0 is equal to negative 16t squared plus 75t. And then now I just need to solve for t. In order to solve for t here, what I'm going to do is I'm going to GCF a t, and we're going to find I have negative 16t plus 75. And remember, once we have it in factor form, either t is equal to 0, that makes sense. When we initially started, the golf ball was at the ground at t is equal to 0. And the other value is going to be when the second parentheses is equal to 0. So 16t is equal to 75, or in our case, t is equal to 75 over 16. And that's going to be in terms of seconds. So how long is the ball in the air? So it is in the air for this many seconds. So I'm going to write that down. So let's go to the second part where it's asking us how far did it travel horizontally? Well, we know how long it was in the air. That's how long it was traveling. For horizontally, we're going to plug it into our x equation. So we're going to get 75 square root of 3 times t, which is 75 over 16. And whatever that value is, that's going to give us the distance that it traveled. And the units will be in feet. So let's go to part C. What was the maximum height that the ball reached? So what we do know about that, we're looking for its maximum height, so that's going to be where y is equal to its maximum. What we do know is that our golf ball is going through a parabolic path. We do know when it finished, and we do know when it started. So what we can determine is that the maximum height occurred right in the middle. So if that's true, we can just sit there and say t is equal to 75 over 16, and we're just going to get half of that, and that's going to give me 75 over 32. So it reaches its maximum height at this time, so we know we've answered the second part of part C, but if we want to know the maximum height, then we're going to stick it into our y equation. So for us, it's going to become negative 16 75 over 32 squared plus 75 times 75 over 32. So whatever value we get there, that will be our maximum height. And our units will be in feet. So from here, that concludes our notes on our trifold. But what I do want to do at this time is to go to the very front of our trifold and finish some information there. As you can see here, our first panel was our title page, and we're going to have parametric equations on there. We already have this part already written, but I do want to add this part right here under parabolas, that if we're looking for the parametric equation, we let t equal to whatever is squared, so whatever that parenthesis is, and then we let t squared equal to the other side. If you're looking at circles and ellipses, you should use the trig identity sine squared of t plus cosine squared of t is equal to 1, or the other way around, cosine squared of t plus sine squared of t is equal to 1. For hyperbolas, you have no choice. You have to use secant squared of t minus tangent squared of t is equal to 1. And that concludes this video.